second example. This is the stone going off the cliff. And I really think a picture helped with this one. So let's draw a picture. I have a cliff. And I know the cliff is 70 meters. And I know I throw it up at 12. Okay? And when it comes back down right here, I also know it's 12. Oops, not 0, 12. And I know at the top, the velocity is 0. Okay. So at first, I'm going to look at above the cliff. So let's write that. We're going to look at above the cliff, and we're going to look at the down only. Alright? So I'm only focusing on that piece right there. Alright. So, I have two equations. I'm going to do this equation. So my VF is my 12. My VI is 0, because it's starting at the top. My A is 10. And T. So I get 12 equals 10T, which is T equals 1.2 seconds. So 1.2 seconds is the time it takes to fall down. And because this is symmetrical, I know it's also the time it takes to go up. All right. I can also look at the distance. So I want to find this distance above. So for the distance, I'm using this. And because x naught is 0, that whole term goes away, which makes it really convenient, which is why I'm always going to be starting at the top. And I need the time, because this is the time down. Well, I just found the time down. That's this guy. Alright. So I plug this in, and I get 7.2 meters. So 7.2 meters is this distance right here above the cliff. It's also the distance here going up. So now I can actually find something. One of the parts is asking me to find the, where is it? What is the total distance the stone travels? Okay, well, the stone goes up, that's 7.2. Then it comes down, that's another 7.2. And then it goes all the way down, which is 70. So the total distance, I'm just going to add those three things up. So the total distance, x would equal the up plus the down plus the cliff. So the total distance would be 7.2 plus 7.2 plus 70. So my total distance is 84.4 meters. So that's one of my three answers. All right. So now I'm going to look at the, let's go back up. I'm going to erase this. So that way we have our picture still here. All right, so our picture's still here. So now I want to look at from the top all the way to the bottom. Top to bottom, down only. All right, so I'm looking at this piece right here, from here all the way down. And I always like that top, because that top, my VI will be 0. And that's going to make the math much easier for us. So because I'm looking at this, I'm going to look at this total distance from the very top to the very bottom. So the total distance, bit plus 1/2 at squared. Because we're starting at the very top, that goes away. So I get x, oops, I actually know what x is. What is my x? My x from the very top to the very bottom, I have this, which is 7.2, plus this, which is 70. So my total distance is 70 plus 7.2, which is 77.2. And I have 1/2 times 10 t squared. So I get 77.2 equals 5t squared. I can divide both sides by 5. And then take the square root. And I get t equals 3.93. So this is 3.93 is the time it takes to go from the very top to the very bottom. All right. So because I know that, I can come over here and I could go, okay, well I know my total time now. My total time is going to be the time up plus my top to bottom. Top to bottom. So my total time would be this time going up, which is 1.2, and this time going down, which we just found as 3.93. So my total time is 5.13 seconds. So that's my second answer. And for my final answer, I'm going to go and look at this speed from the very top to the very bottom. So I'm going to use Vf equals Vi plus At. I don't know what the velocity at the bottom is. I do know the initial velocity is 0, because once again, starting at the top. And I need this time. This time is the time it takes to go from the very top to the very bottom, which is that one. So I can plug that in there. And I get Bf equals 39.3 meters per second. So I hope this cleared things up for you a little bit. Please watch again if it didn't, or ask me for questions. I'll be happy to walk through it again. And before the test, we are having a test in a little more than a week. So before the test, we'll be working on some more problems similar to this too, to really get you dialed in on these. All right, hope you enjoyed this tutorial. Thanks for watching.